What's up, first and second period? This is a video that I'm making in order to kind of help figure out the cooldown, because I know there's been some confusions with it and we didn't really get a chance to finish today's lesson. Doing my best to rework things and kind of change the way I'm doing some of my lessons. Miss Cedillo, who I work with, is having some of the same problems, so we're going to kind of rework some things to make it work better for you guys. That way we have more time to do the cooldowns in class and we can clear up confusions there. I really don't want the lessons to keep going as long as they have been. But for this problem, we're going to use the first 5 terms of each of these sequences to state if it's arithmetic, geometric, or neither. Then we will define the sequence recursively using function notation. We have these 6 different sequences and we're going to look at them. First one is called A. A is the name of this sequence. It's a function, so we're going to use A to represent the function notation when we write an equation for this. First thing we should do when we look at any sequence is try to figure out what the pattern is. I notice this sequence goes from 30 to 40, 40 to 50. Should be pretty obvious that this sequence is adding by 10. Sometimes it might not always be obvious that we have a consistent pattern here, or what we're doing in terms of like addition in some cases. So we could always find a common difference between sequences or between terms in a sequence by taking the next term and subtracting the previous and seeing if that ends up being the same thing. So I could do 40 minus 30, or that should be equal to 50 minus 40. Any of these always should get a common difference of, well, 10. Therefore, since we have a common difference, that is, we're adding by 10, that makes this an arithmetic sequence. Because we're adding by a constant that we call the common difference, which happened to be 10 in this case. Big thing now is that we want to start to define rules for our sequences. Our rules involve some equations. As I mentioned, this sequence is named A. First thing we should always do is write the first term. In order to use a recursive definition that's going to tell us how to get to the next term, we have to know what to start with. So in order to write the first term, we'll say A, when the input is 1, is equal to whatever the first term is. If we look at it, it's 30. This means that this is the first term of sequence A. That's what this A of 1 means right here. The first term of sequence A. And we know that it's equal to, well, 30. So that's how we start out our recursive definitions every time we need to say what to start with. The first term in this case is 30. After that, we're going to define how to get to the next term. This is where our actual rule starts to follow. So we're going to say, well, how do we get from one term to the next? As a statement here, if I were to describe this, to get to the next term, 40, I know that it's 10 more than the previous term. Or, in other words, we have to take the previous term and add 10 to it to get to the next term. So we'll say A of n. This means the next term. A of n is referring to the next term. To get that, we're going to take the previous term and add 10 to it. A of n minus 1 is the previous term. Why though? Why is n minus 1 the previous term? Well, if I did a little off to the side here, if I had a of 3, well, the term previous to that would be a of 3 minus 1, which equals a of 2. Or if I had a of 5, if I wanted to find the term previous to that, it would be a of 5 minus 1, which equals a of 4. So you can see that all we have to do to mark the previous term is to subtract 1 from wherever we're at. But in our case over here, we're working with the nth term. Well, to get the previous one, we just subtract 1 from it. All right, and then we're going to add 10, because that's our pattern here. I'll do that in green. Adding 10. Since we're adding 10 to the previous term to get the next term. And last thing, when we write this, we need to specify what n could be. In this case, if I were to plug in a number like 1, 1 minus 1 would be 0. And we don't have a term before the first term. There's no 0 term in this sequence, so that wouldn't make any sense. The first value that's possible for n is 2. Because 2 minus 1 would give us 1. So it would be taking the first term plus 10 to get the second term. So we would say that this is for all n greater than or equal to 2. Can't be bigger, or can't be less than 2. It has to be equal to or more than 2. And there's a recursive definition for this first sequence. All right, let's take a look at this second one here, sequence B. This time we go from 80 to 40. I could see maybe I subtract 40 here, but if I kept that going, that's not true because 40 minus 40 would be 0. So subtracting 40 doesn't work. All right, so now maybe we need to find a growth factor. To find a growth factor instead, we can divide consecutive terms. Maybe it's multiplying by something basically. So I can take the next term, 40, and divide the term before it, 80. 40 divided by 80. If you simplify this, should equal 1/2. Why? Because if I divide 40 by 40 and 80 by 40, I get 1/2. So the growth factor here is 1/2. That means that to get from one term to the next, all we have to do is multiply by 1/2. Which is coincidentally the same thing as dividing by 2. Multiplying by 1/2 and dividing by 2 is the same thing. And now that we know the pattern, we can start to write our rule for this. Again, we'll start by writing the first term. This sequence name is B, so we'll say the first term of sequence B is equal to, looking at the sequence, it's 80. And then we want to say, to get the next term, B of n, whatever any term is, we basically want to know how we can get to the next term after we start with 80. We'll take B of n and say that it's equal to the previous term, n minus 1, times our growth factor, 1/2. We know that's true because to get to the next term, we have to multiply the previous term, 80, by 1/2. Or to get to this next term, we would have to multiply the previous term, 40, by 1/2. Or to get to 10, that next term, we would have to multiply the previous term, 20, by 1/2. And again, n can't be 1 because that would make the previous term the 0 term, which doesn't exist. So this is going to be for all n greater than or equal to 2. I'll do one more and leave the remaining 3 for you. This one we knew, I forgot to mention, was geometric because we're multiplying by that growth factor. Alright, and this last one, or not the last one, but the third one, C, we have to figure out the pattern. How do we get from one term to the next? So again, doesn't look like it's adding by something. If I add by 1 here, I'd add by 2 here. Seems like it's adding by something that varies. Add by 4 here, so that's not working for us. It's not arithmetic. Well, maybe there's a multiplication pattern here. To check, you could always take the next term and divide by the previous. This is the growth factor equals 2 divided by 1. Or is that the same thing as 4 divided by 2? Yeah. Or we could take the next term 8 divided by that previous term, 4. Any way we look at it, we see that there is a growth factor of 2. So we can multiply by 2 to get from one term to the next. Therefore, this is a geometric sequence since we have a growth factor. It's multiplying by a constant. Okay, and now we need to write our rule. We'll start off with our first term. This sequence is called C. So C of 1, the first term of sequence C is, well, 1. And to get the next term, C of n, it'll be equal to the previous term, C of n minus 1, times our growth factor. We know that's true because to get to the next term, 2, we would have to multiply the previous term, 1, by 2. To get to the next term, we would have to multiply 4, or the next term 4, we would have to multiply the previous term 2 by 2. To get to the next term, we would have to multiply the term before it, 4, by 2. Therefore, we're multiplying the previous term by 2. And again, this is going to be for all n greater than or equal to 2. Alright, so hopefully this helps you out a little bit with it. Definitely recommend doing 4, 5, and 6 as practice with this, and the cool down as well.